Welcome to our webinar, PÖTTINGER, Heading Forward to Innovation and Continuity. At the beginning, I would like to especially thank to our loyal attendees who join our webinars again and again. Thank you very much. My name is Andrea Zetta. I work for the Austrian Chamber of Agriculture in Vienna, which is a partner in the Smart AgriHubs project. We lead the regional cluster, Central Europe. This cluster includes Austria, Czech Republic, Slovakia, Hungary, and Switzerland. After I have said a few words about Smart AgriHubs and the Smart AgriHubs initiative, I will hand over to our special guests from PÖTTINGER, Dr. Markus Baldinger and Ms. Lisa Wöß. They will explain how research and development is organized at PÖTTINGER and how they see digitalization moving forward. Please, if you have any questions or comments, use the chat function and we will address them at the end of our webinar in the question and answer session. Let's move on to the Smart AgriHubs project now. Smart AgriHubs is based on the Horizon 2020 research funding program. At the start of the project in November 2018, there were already 168 partners. The project aims to accelerate the digital transformation of the European agri-food sector. This is achieved by building an extensive European-wide network of digital innovation hubs. These hubs boost the uptake of digital solutions in the farming sector. The core of the project is formed by 28 flagship innovation experiments. In these experiments, ideas, concepts, and prototypes are continuously developed and brought to market. During the open call phase of the project, 5.7 million euros in funds were awarded for further innovation experiments to develop technological solutions to the major challenges of the agri-food sector. So over the years, Smart AgriHubs has become one of the biggest European platforms for digital agri-food innovation. The main management platform is called Smart AgriHubs Innovation Portal, which enables networking with hundreds of innovative actors across Europe via a unique networking map. It provides information on external funding opportunities, events, and trainings you can find on the website. Have you registered yet? If not, you should do it today. There are only advantages for you. And I have forgotten the forum. What is the forum? The forum, in the forum, you can post your questions on a wide range of topics. That's all for the introduction of Smart AgriHubs. But now it's time for our main speakers today, Dr. Markus Baldinger and Ms. Wöß. Dr. Baldinger is the Chief Technical Officer and responsible for research and development and digitalization. He's also the chairman of CEMA's technical board. CEMA is short for the European Agricultural Machinery Association. He was elected in 2016, and after this first term, he was re-elected chair. Ms. Wöß is the head of innovation and and management technology, and responsible for collaboration with startups, and in addition for digitalization and new business models. We are honored to have you here today. Please share your screen with us now.
So, hello to the digital community and warm welcome from our side. It's a pleasure for us to have a short introduction and an insight into our R&D department, and to give you a short feedback, a short outcome to the future of the digitalization. As you can see here on the first slide, the company PÖTTINGER, we have expanded our portfolio. I don't know exactly if you know it from the past, and we have expanded in a few new areas. As you can see here in the middle of the picture above, some crop care machines, or in the middle to the left side. We are also in the arable farming, the picture on the above left side, and also our grassland products down at the bottom. On the right hand side, you can see here some digital products, but we can show you these products a little bit later. So where do we come from and how are we founded? When are we founded? You can see here our slogan for the company PÖTTINGER is more success with PÖTTINGER. This means that we want to give our farmers the possibility to get more success with our machines, and this is one of our main slogans for our company. The company PÖTTINGER was founded in 1871. It's more than 150 years old. We have our anniversary, our celebration last year for 150 years. And the company was founded by Mr. Franz PÖTTINGER. He was the great grandfather from these two guys who are, you can see here on the picture. On the left-hand side, we have Mr. Klaus PÖTTINGER, and on the right-hand side is Mr. Heinz PÖTTINGER. These two guys are the two owners of the company, so it's totally a 100% family-owned company, and everybody has a share of 50%. They entered the company in 1991, and at the moment they're sitting in the advisory board. And we have a managing board where I'm responsible for the technical part for R&D and digitalization, as mentioned. How does everything begin? We say from the beginning we have to honor the past, but we have also looked to the future. But let me give you a short insight where are we coming from. In 1871, Mr. Franz PÖTTINGER, who is here on the picture on the right above picture, has won a silver medal at the Linz Festival. Started it's in Linz, so-called now Urveranermarkt. He has won a silver medal with a cutting machine, forage cutting machine. You can see it here on the right down picture at the below. In 1999, his son Alois takes over the management, so it's the second generation, and he begins to produce fruit mills, fruit presses, silage, and forage choppers. In 1960, it's one of our milestones as well. We are expanded and started to build our headquarters here in Grieskirchen, where we're sitting now. This was started in 1960, and in 1963 we began to develop and produce the loader wagons, where we are world market leader with a total market share of around about 40%. In 1971, a new acquisition, or first acquisition of the Bavarian plow factory was done in Landsberg am Lech. So we entered the arable farming issue. So this is also one of our next milestones in our company. We say the adventure continues. In 2001, we took over the drilling factory in Bernburg in eastern Germany. And therefore we closed a gap in the product range of the arable farming. So now we have also drilling machines and plows in our portfolio. In 2007, we can see the picture above, below, here below, I'm sorry. We decided to build a new factory plant in the Czech Republic, and this is now responsible for tillage machines. 2018, we also built a new plant for the logistics. It's in Taufkirchen, close to Großkirchen. And here on the middle picture, you can see our headquarters in Großkirchen. In 2021, we expanded and we decided to build our fourth production plant in St. Georgen, who is close to Großkirchen, around about 5 kilometers far away from here. The R&D department, here are a few facts and figures from our R&D department. In totally, we have 1,929 people. We have employees all over the world. We have people from more than 36 or around about 36 nationalities. Here in Austria, in the headquarters, we have around about 1,134 employees. In Germany, 189. In the Czech Republic, for more than 400 people, and worldwide, these are sales guys and after sales guys, around about 170 people. These are facts and figures from the financial year 2021. So what are we standing for? As we have mentioned, we are responsible, or we want to be a producer for arable farming. And we say we want to give the farmer the best soil. So soil is essential for the lives, since it provides the basis for the high quality nutrition. We took over this challenge, and we want to offer machines where the farmer will get with our machines this best soil. And which machines do we offer? This can be seen in this slide. This is the product range for arable farming, and as you can see here on the picture on the right-hand side, we offer a lot of products where we can say nearly the whole process for arable farming can be offered by our products. We can start with the plows at the beginning, then the stubble cultivators, the disc harrows, the power harrows, the compact combinations, the seed drills, and the crop care machines. We offer plows for different range, also the stubble cultivators. The machines are from 3 meters up to 10 or 12 meters, and the seed drilling machines are up to 9 meters, for example. We are also coming from the grassland area. So in this area, we want to provide the farmers the best forage. Here we can say that this high quality from the grass is one of the main factors for getting the best milk and therefore the best money. So we want to do this job also with our grassland machines. And these grassland machines and this process chain, can you see here? We offer the total process chain for the grassland equipment. As you can see here on the right-hand side, we started with the mowing process, then with tillers. You can see it also on the left picture. Tillers from up to 18 meters or around about 18 meters. Then the rakes up to 14 meters, one rotor rake up to 4 rotor rakes, and then the loader wagons, where, as I've mentioned, we are world market leader, and we started a few years ago also with the design and the development of round balers, so we can offer here the whole grassland chain. What is our vision for the future? And there is the connection also to the future. our vision is we want to stay and to be a family-owned business company. We want to stay financially independent. This makes it ongoing growth. We want to offer quality products for a lot of different kind of farmers, contractors, and machinery rings, as well as for major agricultural business. We want to make our farmers with this working more successful. So if they need to use our machines, we say they are more successful than its competitors. We stand for a sales philosophy based on partnership and have a reliable distribution channel. And we are committed to building on our Austrian roots and our top employees in this region. And the connection to the digital future we can show you in the next few slides. So I will hand over to Lisa, please.
So hello from my side. I just want to have a quick look through the history first. So from the past to the future. Here you can see the four agricultural revolutions. The first one was the adoption of modern agriculture. The second one was the mechanization post World War I, which was the invention of the internal combustion engine, which was the first major step in the increase in the productivity. The third one was the Green Revolution, where most increase of the productivity was based on inventions in chemistry. So it's the nitrogen and phosphate fertilizer, which was the basic on the increase of the productivity. And now we are in the fourth revolution, digital revolution. And that's what we are talking today. And we want to give you a short insight in the digital revolution at PÖTTINGER. First of all, we have some trends and impacts where we see the most revolution, revolution in agriculture. It's on the one hand the smart farming or precision farming as well. As you can see on the picture above, it's more or less digitization of everything on the field. So it's from humidity to temperature to the single plant. That's one thing. Then we have the augmented reality and the virtual reality, where we can give you a short insight in the virtual fair or an example at PÖTTINGER. Afterwards, we can show you this in a live demo where we have where we did a project with the startup. Then we have the IoT and connected devices and the big data, cloud computing, as well as edge computing. The AI in agriculture will be a major technology in the future, we think, and we have the robotics and autonomous machines. Maybe you know the robots on the right-hand side. And what's very important or interesting for my business, for innovation and technology management, it's a new business models. How can we earn money in the future? Do we earn money in the future with machines, with telling machines, or do we earn money with telling data or helping the farmers to get out the best of their resources?
So then let's talk about the future, or where we are standing now at the moment. Lisa has told you some trends and impacts on the egg industry, and you have seen a few figures or pictures on the right hand side. For example, the cow with this virtual reality glasses. So what can we see in this issue of the agricultural 4.0? Let me start with the right-hand side. The user should be always in the middle of the development, always in the middle of the new scenarios. So this user has to interact and then has to get some output from these new technologies. And we have shown you here on this picture the core technologies of agricultural 4.0, as we can see. And I want to explain it to you from the left to the right-hand side. And let me start with the first pillar on the left-hand side, the sensors and robotics. So what are the differences to the past? We get more and more sensor technologies on our machines. We get more and more possibilities to use the one or other robotic machine, either small machines for only detecting, or in the future also for self-propelled or self-propelled machines for some small robots like they're using our machines. With these sensors, we are sensing or perception the environment. Therefore, we get the information how the machine works in the field. And on the one hand side, we need the sensors. On the other hand side, we need also the actuators, so that we can react on this information based on the sensors. This is a technology who is installed directly on the machine, but we need for processing of this data. This data is also not only on the machines. We need it also in the computer, at the farm, or at anywhere, or in our company, for example. So therefore, we need this second pillar, as you can see here, the Internet of Things pillar, which means we need some communication units directly on the machines who are connected through the internet. So all of these new sensor technologies, all of these new sensor data should be connected directly to the internet. For example, as Lisa has mentioned, either on the machine, the sensor data, also the data from, for example, the plant, the humidity of the soil, something like this, and maybe in the future as well, some weather data, or from the cloud, or from the satellite. With this communication unit, we send this, let me say, big amount of data to some storage informations. In the past, we have some embedded computing systems, which means that the computers are installed directly on the machines. But with this huge amount of data, it's not possible to react directly with these computers on the machine. So we need it to transform it into the internet, into the cloud. Therefore, we have to pre-process some kind of information, though that it's not too huge. And on the other hand side, we have to store it directly on the cloud. This is more about this third pillar. And then let me come to the fourth pillar. As we have mentioned before, we get a lot of amount of data. You can call it or see better with big data. So what are we doing with this big amount of information? It's really very, very difficult for a human being to transform this huge amount of data into information. And what are we doing at the future, or up to now? We are beginning with these new technologies. We use these AI algorithms. Therefore, that with this huge amount of data, we get information where some computers can react or act about this information. So then this is the fifth pillar. This is the decision and the support system. So we get this output of these AI algorithms This output presents us some information where we can make some decisions on this recommendation. The AI algorithm is not therefore for doing the job by its own. He gives us only some feedback or some information, and we can do from the user's perspective it by our own. So we get some decision-making recommendations where we can then say, go to the left or to the right-hand side. And on the other hand side, we get some visualization of this data. So it's much easier for us to get an overview about the process, how it works. So this means the so-called steel and iron machine from the past, which we are producing 150 years ago, will transform into a mechatronic system in the 2000 years, up to a digital system now in 2020, and therefore we get this new information, which we call agricultural 4.0. So then let's come to a few slides of our R&D department at Pöttinger. Here we have some facts and figures, with how many people are we doing this job. As I've entered the company more than 20 years ago, we had, let me say, 5 or 6 disciplines. At the moment, we have more than 15 different disciplines in the R&D department. So the effort for the R&D department is growing and growing. We have an R&D budget of around about 18.3 million euros. It's around about 5% R&D rate, with perspective to the turnover. We are doing our job with 152 employees located here in Geskirchen in our headquarters. In total, we have 177 people all over the world, let me say, but we have these people sitting in more or less in our production plants, the rest of this 15 people. 25 people, I'm sorry. What are we doing? What are our jobs? We are doing 23 serious development projects in parallel, which means we have a lot of projects in parallel, and we get from this project around about new product share of 20%, which means 20% of our machines which we are selling each year are new machines, new products. And we are also testing our machines in our technology center. And in the technology center, we are making these tests and let me say an inside testing scenario. And in this testing scenario, we have round about 94,000 hours where we are testing our machines for stability so that it fits to the farmers.
Okay, Markus, thank you. Now I will show you the R&D process in detail. Unfortunately, it's in German, but I will give my best to translate the terms. At the bottom, there is the pre-development, but let's start on top. So we are doing trend analysis in the innovation management, as well as the market and technology intelligence. And the product management is doing all the job in environmental analysis. So it's they are doing the analysis in several factors like the political, environmental, ecological, social, and legal factors, as the pestle analysis supports this. And afterwards, we are gathering all the informations. And then we are defining search fields where we want to focus on. So we are defining, let's say, sensors for getting the information about the processes. And then a project team is looking for the sensors and how to adapt it or implement it in the at the machines. So we divide the projects in pre-development projects where the uncertainty is bigger than in serial production projects, where we know exactly what we want to do and how to do it. So the uncertainty in pre-development project is bigger. Sometimes we do not know if the technical aspects are working. Sometimes we do not know if the customer needs are fit the product, and sometimes we do not know if the real the prices will fit the customer needs. So then we need to do a pre-development. After the pre-development is successful, we enter the serial development process. And the serial development process is a quite huge process. Usually it lasts from 2 to 4 years to go from gate 1 to gate 10. So it's the kick-off gate at gate 1, where the management board says, okay, you can go through the project. We need this new product or this new machine. And then a team has the challenge to and the goals for the project, and then they go through the process. So it's from G1 to G10, 2 to 4 years. The major aspect in this process, or the phase where it takes the most time, is the testing phase from G5 to G10, G8. But the most important thing from the innovation perspective is the G1 to G5, where all the developments were made, where the design engineers, the mechatronics design the new machines, and they do a lot of virtual testings with several tools.
We tried to give a lot of our efforts in these first 5 stages, or the phases. So we want to have a front loading of the process where we can have a detailed look on the concept phase from G1 to G3, and as well as for the development phase up to G5. And you can see here, for example, the gate number 4 is the virtual prototype. So we're doing a lot of our things also in the virtual scenario. And with G5, we get the feedback for the team that they can beginning to build the prototype. And then we are going to this testing phase, and from G8 to G10, this is the serious production phase, where we're going directly to the start of production process. So we divided into this 10 gates, and therefore we get always enough feedback where the development of the product stands, and therefore we get really good feedback how we are going on, and how our product is fitting to the customer. And this is the main issue what we want to get for this process as an output.
Yes, and in 2018 we have implemented the agile product processes, and all of the serial development projects, which Markus mentioned before, are in agile. So we have the system like Scrum in software development, and we implemented in the hardware. Next slide. So that's the slide I've mentioned before, the virtual fair. This was more or less by accident, because it in 2 years ago the Corona crisis, and there was no fair. And luckily we had a startup in Linz. They contacted us and say, hey, let's go do a virtual fair. And now I'll show you the result.
So therefore we have a big interaction also with our community, and they have the possibility to see our new products in this fair. So this was really a very positive development, and we get a big interaction also with our customers.
So every one of you can visit the virtual fair afterwards. It's part of our website at PÖTTINGER.com. But we show you some insights now. You can go through the virtual fair. And first of all, I will show you the sensor safe. Maybe Markus have mentioned it on the first slide. And I will give you a short introduction in this video.
So you can see here our mower combination with the front and the rear mower, and these white bars are the sensor safe bars, and they should detect the animals on the field. And you can see here that they can detect it and send a signal to the tractor cab. The tractor has not stopped, it's only stopped here in the animation, and he has to lift up the mower. And as you can see here on the left-hand side, we have detected the animal, and we don't have mowing it.
Here is the solution for the front mowers, but it's basically the same
situation. We lift it up, and therefore we have these animals on the field, and we can save it.
Okay, and one more insight in digital farming, as it's part of the webinar. Here we have a short insight in the digital farming activities of PÖTTINGER. As we have mentioned it before, the cloud, the AI, the agri-route, and the next machine management.
Yeah, as you can see here, directly in the middle, we can see the AgriRouter. We are shareholder of AgriRouter. We are a lot of our competitors together with us are shareholders of this system. We call it an open system, so that everybody can transfer his data through the AgriRouter from one endpoint to the other endpoint. And you can see here, you can send the data from the left bottom machine, from the arable machine, from the drilling machine, through the AgriRouter, either to the cloud or to some terminals, or to the next machine management. It's the farming management system on the farm. And via the cloud, you can also send a lot of data to some different kind of processes. So this is the vision where we are going and where we are developing our machines in the future.
And one more brand new machine is the new Mercento. But we want to stop now because of the time, but you can visit the virtual fair on your own and spend a lot of time on the fair.
So you have the possibility to see all of these new machines directly on this digital fair. And if you have any questions afterwards, you can send us some emails or some informations. Thank you very much.
Thanks.
Thank you. I would like to thank both for the very informative presentation on PÖTTINGER. We have now about 90 minutes left, and we can move on to the question and answer session. A few questions have come in, And here's the first question. I don't know if it is a question for Dr. Baldinger or for Ms. Wöß. So I will ask you, one participant asked, how do you see the real demand for digital tools and technologies from the farmer's side?
Okay, from the farmer's perspective, we can say we don't want to make digitalization from the digitalization perspective. We want to make his job easier, and as we have mentioned at the beginning, we want to give him more success with our machines. This means in the past we have designed the machines from the mechanical perspective so that he gets more success. And in the future, we want to give him more possibilities in combination with this digitization. And therefore, we think we want to know his needs. And on these needs, we want to design these new digitization systems.
Mm-hmm.
From my side, I can say that I think farmers today are actually aware of the need for sustainable resource management, and digitization or digitalization could be one answer on sustainable resource management.
Mm-hmm. Thank you. There is another question. So looking at public discussion about digital farming, crop farming technologies seem to be in the center of the debate. Do you think that development in grassland technology is moving forward more slowly than in arable farming?
It could be that it's not this velocity is in arable farming, but we have also launched a new technology for the grassland farming scenario. This is the technology which we called harvest assist, where we give the farmer the information from the grassland process chain, where you can see where the rake is going on the field, and you get an information if the rake has done its job. You can enter it with a loader wagon, and therefore we want to optimize the grassland process. So this is our first step also at the grassland development chain, that we can give the farmers the possibility also to use this digital informations in the grassland process. But I also confirm that in the arable farming, the velocity is a little bit higher.
Mm-hmm. There's also a project in an innovation farm with the harvest assist, not?
Yes, correct.
It's running this year.
Yeah.
Mm. So if people are interested, they can go also to the website of Innovation Farm and can find the project, your project there.
Yeah,
it's part of our website and part of the website of Innovation Farm.
Okay, thank you. And there's a last question. How do you see the discussion about data sovereignty? Some farmers seem to be concerned about that. Should they be concerned?
Data, I have not understand. I'm sorry.
The data sovereignty.
Okay. What we can say from our perspective is that all of the data are only the farmer should use it, and they're part of the farmers, and we have to get in a contract or any contract with the farmers so that we get a short number of these data. But from the beginning, all of these data belongs to the farmers. This is our perspective.
Mm-hmm. Okay. Thank you so much. Well, then we have finished the Q&A session. Before the webinar ends, I want to briefly mention our upcoming webinar. It's called T for Dairy. We are delighted to invite you to the last webinar in this series in September. The project aims to further develop digitally supported management for dairy farms to improve animal health, animal welfare, and product quality through data-based networked information systems. Save the date now. And now we are coming to the end of our webinar. As you might know, it is also very important for us to hear your opinion about our webinar today. I would like to ask everyone now to provide feedback on this webinar in Zoom. Thank you very much again to both speakers. Thank you very much to our technical support, Mr. Gerald Fabigan, who managed the technical support for us. Thank you for joining us today. Hope to see you in September. In the meantime, I wish you a nice summer. Bye for now. See you.